Welcome to the world of computer networks. In this video, we'll talk about error control in the link layer. So let's start the session with the outcomes. Upon the end of this session, you will be able to understand why we need to deal with errors in data communication, what are the types of errors, and finally we will see the error detection techniques. So let's start with what is an error control. The basic service of a link layer is to move a datagram from one node to an adjacent node over a single communication link. When a signal is transmitted over a communication link, it is subject to attenuation and electromagnetic noise. So the link layer hardware in a receiving node can incorrectly decide, for example, that a bit in a frame is 0 when it was transmitted as a 1. This is called bit errors. Of course, because there is no need to transmit or to forward a datagram that has an error, many link layer protocols provide a mechanism to detect such bit errors. This is done by having the transmitting node or the sender node include what we call error detection bits in the frame. These bits are also called redundant bits. We will need that the receiving node or the receiver perform an error check based on the previous redundant bits. So before talking about how to detect errors, let's see what are the type of errors. Basically, we have two types of errors. Number one is bit error and number two is burst error. So let's start with what is a bit error. In a bit error, only one bit in the data unit has been changed upon the transmission. We will explain that in this example. We have a sender and we have a receiver. The sender is sending some information, but the receiver is receiving a different information. In this example, we can see that there is a change in exactly one bit, which is the fourth bit. So at the sender side, the fourth bit is a 1, but after transmission, the receiver has a 0 in the fourth bit. All other bits in the data unit remain unchanged. When there is only one bit change, we call it a bit error. In a burst error, two or more bits in the data unit have changed. In this example, the receiver is receiving different information that was sent by the sender. We can notice here that there are 3 bits that are corrupted: the 3rd, the 4th, and the 7th bit. To calculate the length of the burst error, we start from the first corrupted bit to the last corrupted one, which is 5 bits in this case. So we can say that in a burst error we have two types of information. We have the length of the burst and we have the number of concerned bits in this error. Let's now see how to detect these errors. We have seen earlier that the transmitting node must include an error detection bit in the frame or a redundant bit, so the receiver can detect these errors. So at the sending node, let's consider the datagram that the link layer receives from the network layer. Let's consider data D as the combination of the datagram and the link layer hidden information. To be protected against bit errors, a redundancy function creates an error detection and correction bits. We will call them EDC. Both D and EDC are sent to the receiving node in a link level frame. At the receiving node, a sequence of bits, we call them D' and EDC' is received. Note that D' and EDC' may differ from the original D and EDC as a result of in-transit bit flips. The receiver's challenge is to verify whether or not D' is the same as the original D, given that it has only received D' and EDC'. So the check-in function will answer the question whether all the bits in the receiver data unit are unchanged or not. If they are the same, the datagram is delivered to the network layer. Otherwise, an error is detected and the data unit is not considered by the receiver. I have to see that even with the use of error detection bits, there still may be undetected bit errors. So the receiver may deliver a corrupted datagram to the network layer. We just want to choose an error detection scheme that keeps the probability of such occurrences as small as possible. We talked about error detection, now let's see what is error correction. An error correction is like an error detection, except that a receiver not only detects when bits error have occurred in the frame, but also determines exactly where in the frame the errors have occurred and then corrects them. Error correction can be handled in two ways. The receiver can ask the sender to retransmit the entire data, also called as backward error correction, or the receiver can use an error correcting code which automatically corrects certain errors. Many codes exist and we will see them in another video. We talk about redundancy functions, so let's see the different techniques that exist for error detection. There are basically three types of error detection techniques that are used in data communication. The first one is parity check, the second is the checksum or arithmetic checksum, and the third one is cyclic redundancy check or CRC. Some protocols use CRC and others use checksum. Checksum and CRC are very familiar techniques in data communication protocols. That is guys, thanks for watching and see you in another video.